SwayamPrabha. Digital India. Educated India.
Hello everyone. So, we are discussing the ballistic protective textiles. So, in last session we were discussing the textile composite as ballistic material. So, here we have first defined what is composite materials. So, by combining two or more constituent material, one of them will be textile material. This we have already discussed, and the basic textile fibers which we use for composite is aramid fiber due to its high tensile strength, good thermal stability, also ultra high molecular weight polyethylene, extremely high strength to weight ratio, very light and excellent energy absorption, but the problem with the ultra high molecular weight polyethylene is it is a lower melting point that we have discussed. Along with that, glass fiber, basalt also used. The basic function of matrix also we have discussed, which binds the reinforcement fiber together and transfer the load from one fiber to another fiber. So, that it the total structure takes the load, and elastomeric matrices are also used, where we try to enhance the energy absorption by deformation, and also it is used for protecting the or resisting the delamination. Nanomaterial reinforced composites are also used for ballistic material. Now, let us try to understand the mechanisms. So, the different stages for protection by the textile composites. So, the stage 1, here we can see when any projectile hits the composite material, there will be deformation, and this deformation actually results in absorption of energy. The fibers stretch. Here you can see this is the fabric, where after the projectile hit, this textile material, this composite actually deforms. This deformation results actually due to the stretching of fiber. So, as the fiber stretches and the composite structure deforms, you can see at different level of deformation, and sometime fiber breaks, but during this process it absorbs projectile's kinetic energy, where you can see the projectile at speed, when it starts it gets deformation, there is a deformation is there. So, which is responsible for absorbing the kinetic energy of the projectile. Now, the second point is a very important point, where due to the deformation and that the impact force is distributed with wide area. So, this energy, that delocalization of impact, so this impact is actually distributed to the larger area, and as it is the area is more. So, it actually the energy dissipation will be faster without damaging the fabric. So, energy is spread over wide area through the fabric weave, because the fabric weave is actually they are interlaced. So, even from the warp it is getting transmitted to the weft direction due to the interlacement of the fabric and the frictional contact, frictional force between the yarns. And third stage is that friction and interply delamination takes place. So, as the force is very high, when the force is very high, the layers slide against each other, because the composite is made of multi-layer. Due to very high force, the remaining energy will be absorbed by the delamination. We can discuss here. So, suppose this is multi-layer structure. So, one layer is shown by the red color, this is a one layer, and now the second layer, this is the second layer, third layer, and so on. These are different layers, and when there is impact due to the weave structure and fiber stretching, the energy is absorbed. But if the load is very high, the impact force is very high, then they will start sliding past each other. So, that is delamination will be there. There is a, this is one like the second layer is, this is the second layer, say third layer, third layer, this type of, and it has slided past. Due to this delamination, I am showing in a simplified model. Due to this delamination, what happens? It will also absorb additional energy. So, energy dissipation will be there. So, there may be different types of delamination. So, there are three ways. One is by the fiber, stage 1, due to the fiber stretch. Due to the weave structure, the energy get delocalized, where the large area will be responsible for absorbing energy. And third one is that delamination, because that frictional force will be there, interlayer frictional force will also absorb the remaining energy. So, by these processes, the composite, textile based composites absorb the kinetic energy. Now, basically there are certain advantages if we compare with the metal. So, unlike metal, the preliminary that resists the penetration. So, metal if you see, which is hard material, it will resist the penetration of any projectile. So, this is a projectile, it will resist the penetration due to its hardness through that. But composite material, if the composite material is there, what it will do? It will start deforming and it will dissipate the energy. So, composite absorbs the impact and dissipate energy through their structure. So, that we have already discussed. So, metal type of ballistic material will prevent it from the projectile from penetration, but it will and for composite it will allow and it will deform and dissipate the energy. So, effectively what we are getting? It will reduce penetration and lower blunt trauma impact. In case of metal, there will be high blunt trauma impact, and there we have already discussed that the metal can get damaged, catastrophic break, catastrophic damage will be there of the structure will be there. But in case of composite material, it will deform and it will reduce the penetration and lower the blunt trauma. So, there are many advantages. One advantage is that it is a lightweight. Strength to weight ratio is very high for composite. So, at lighter weight we can get higher strength. So, if you see the strength will be same for very lightweight. So, that is the main advantage of composite material. Along with other advantages, the textile composite offer comparable or superior ballistic protection at a fraction of weight of the metallic armor. So, the weight of textile based composite will be very very low as compared to metal, it is a fraction, but we can get comparable protection, and sometime if we design the composite properly, we can get even better ballistic protection. So, due to the lighter weight, what we get? We get increased mobility. The person who is wearing that he can move freely and do his performance properly. And for vehicle, if we use this is for vehicle, due to the lighter weight of bulletproof vehicle. So, its fuel consumption will be lower and enhance the payload capacity. So, the vehicle itself is a lower weight. So, it can take higher load payload for the rescue or defense activities. Another advantage of this composite material is that multi heat capability. That is a great advantage. In case of hard body armor, when one bullet hits, if there is any crack formation or if it is any damage formation, we cannot use the same protection, same material for the next. We have to replace that material, that gadget, that portion we have to replace. But in case of composite material, it can sustain multiple heat. So, here you can see in a composite material, if there is any projectile heat is there, bullet heat is there. So, that portion will be damaged partially, but it will keep other portion intact. Okay. So, multi heat capability is there, it will not actually structure will not disintegrate immediately, structure will remain there. So, basically the layered structure of textile composition. Here you can see the layered structure. This is some matrix and then layer of textile another. So, layered structure of composite allows them to sustain multiple impacts in close proximities. Here you can next places we can have some heat. So, better than the monolithic metal plates. So, metal plate it may get cracked or may dust formation is there, that is that we have already discussed. So, damage is localized, here the damage is localized, and in case of metal, so there may be a crack formation or ceramic crack formation is there. So, here only damage is localized and surrounding fibers layers remain intact, that is the advantage. Here if there is any at all any damage, it will be localized. So, that is the advantage of the composite material. So, reduced swell and fragmentation. You can see here for metal, if projectile hits, any bullet hits, so that will actually causes the fragmentation, or ceramic or any other material. So, it will cause fragmentation and totally catastrophic breakage will be there, some dust formation will be there. But in case of textile composite, this is not, this swell and fragmentation will not be there. So, problem with metal is that when struck, the hard metal can generate dangerous secondary particles. So, swell will be there on non-impact side. So, what happens, suppose someone hits in one of the particular portion of the body, and this whatever the secondary particles generated, that may damage other part. So, that will actually reflect, generate at high speed these small particles, they will come out and that may hit other part which has not been already impacted. So, that is very dangerous here, but this is not the case in case of the textile based composite. So, composite is that fibrous nature of the textile significantly reduce and eliminates the swell. So, the some particles coming out is not actually present in case of composite structure. So, enhancing the safety. So, in the bullet here suppose hits in some places, it has not penetrated, it has been reflected, but that the particles, secondary particles which has been generated, that may damage in case of metal, but in composite that secondary damage, the chances are negligible, it does not happen basically. It is a soft fibrous material which absorbs the impact. So, now if we want to enhance the blunt trauma of the hard armor, hard body armor. So, blunt trauma, in that case what we can do? We can use the soft body armor like your composite along with the metal. So, back face deformation, the deformation of the armor on the non-impact side, that we have already discussed. This is the armor, here there is an impact side, and whatever deformation is there in the other side, that is a non-impact side, that is called back face deformation. And the composite what we get, their ability to deform elastically and distribute energy, which reduces the back face deformation. Now, we should understand this concept very well. We can just try to clarify this point. Suppose this is a metal ballistic material, and here what we are doing, we are putting the, let me select other color. So, this is the backing material is there. This is backing material. Now, this is hard metal. Now, when some projectile like bullet hits here, so this is, as it is hard, it will try to reflect the bullet or there may be damage, but this total solid hard material will impact on this and there will be large deformation maybe this type of deformation will be there, because it will carry high kinetic energy. Due to this energy, this ballistic material will be pushed and there will be deformation, and it will generate very high back face deformation. But in case of composite material, now we can see, suppose this is a composite material and backing material is here, this is backing material. What will happen? Due to the impact, due to this impact at very high energy, the composite will get deformed, and this deformation, as we have discussed, it will actually absorb the energy. So, this elastically deformation will result distribution of energy to the other side with a larger area. As the area increases, so it will result lower pressure on the backing material. That means, it will minimize the back face deformation and it will, thus it will minimize the injury to the wearer. So, hard body armor will result higher back face deformation. And another advantage is that design flexibility and formability. So, for a metal, its formability is very difficult. We cannot have a metallic sheet which will be, it is very difficult. We can have, although it is very difficult to form a metallic sheet in as per our body contour, and even if it is formed, due to its heavy weight and its flexibility will not be there, and also our body movement will be restricted. So, here you can see the picture here. Now, for a metal to form this type of armor, it is very difficult, okay, hard metal. So, here for different size and all this, it is very difficult, but for textile composite it is very simple because of its flexibility, it is flexible, we can have this type of body armor easily. So, here formability is easy due to the flexibility of the material. So, we can do better customization for different person, depending on their size and requirement, we can customize the ballistic material by using the textile composite. So, it can be tailored to a complex shape and sizes. but in case of hard metal we cannot tailor it. So, it for a specific body parts or the in the vehicle contour. So, all this advantage we can consider like its weight is a mass is a mass versus for a specific strength, like for a particular strength mass is low and it absorbs energy. You can customize depending on the requirement. So, for all these advantages we actually prefer nowadays it is a textile based composite for ballistic material. So, also the manufacturing is easier because easier to process into various configuration compared to metal. You can see if we try to manufacture this type of structure in a metal it is very difficult, but here with the flexible textile composite we can simply tailor it, we can stitch it. And to enhance the capability. So, this soft body armor or this textile composite it has some limitations, we cannot have multiple layer and all. So, for suppose this is this type of composite are used for lower thread, soft body armor we can use for lower thread, but where the thread perception is high, in that case we can use the hybrid armor system with the textile structure, because hybrid will be using that hard body armor for higher protection when we perceive the threat, otherwise we can remove it, removable armor is there. So, monolithic hard armor which actually after impact it gets cracked and spell formation is there, but if we use along with the textile composite hybrid composite it will actually remain, the structure will remain intact. So, for optimal performance the combining the ceramic for initial projectile hit. So, ceramic we use at the outer layer for initial projectile defeat, it will restrict the initial this impact, and then the textile composite backing which will help in energy absorption. So, that actually this total structure creates highly effective hybrid armor basically. So, first outside there will be ceramic material or metal, it will actually absorb the initial impact, and the back face signature what we have discussed earlier, which is basically problem in case of hard armor like ceramic or metal, that will be that energy will be absorbed by the composite backing. So, that here we can get better protection with lower back face deformation. So, here the synergy is that each material play to its strengths. So, that we have to use that type of material. Now, other advantage among the other advantages of the composite textile based composite are its resistance to many environmental impacts, like it is good resistant to moisture, UV radiation, chemicals. So, if we select the composite in such a fashion, so we can have our flexibility, we can create a composite which will be chemical resistant, UV resistant or even moisture resistant. Also we can create with high temperature resistant, different types of manipulation we can do with the textile based composites, like you can see here chemical resistant composite, okay. And with the chemical, the composite remains stable, UV resistant. Here in case of other hard armor, there may be some degradation, but for composite material there is no degradation. If you are in metal, there may be rust formation, which is corrosion may be there, okay. But in composite we can develop composite, we can produce composite which is water resistant, okay, and there is no corrosion and it will have longer life. So, this composite can be designed, but metal characteristics we cannot improve easily. So, durability we can enhance. So, as these are chemically resistant, UV resistant, moisture resistant. So, it will automatically have durability, and all this resistance will contribute to long service life compared to some metallic option which are prone to corrosion, or there are different types of environmental impacts like rusting will be there. So, there are different types of manufacturing innovations. Advanced weaving or stitching systems are there. So, normally in we produce the 2D fabrics like plain weave, twill weave fabric, that we can, where thickness of the fabric is very low as compared to the other dimension. That is why we call those fabrics as 2D fabric, but we can generate, we can produce 3D weaving where the different layers we can produce in a single fabric with the different binding layers, binding threads, we can produce this type of layer. So, here the 3D weaving which are used for advanced ballistic material, where number of layers are combined together and they are used to absorb high impact energy. And also one problem with the normal weaving is that the yarns are crimped, there are crimps in the yarn. So, this crimp, what happened when there is a load impact is there, they get stretched, and that will enhance, that will actually increase the deformation without absorbing that level of energy. So, simply they will get deformed. The load on the individual fiber, it comes at the later stage. Before that there are large number of deformation, but this we can design the fabric, we can develop fabric with the straight threads, non-crimp fabric we can develop without any crimp. What will happen here in this type of fabric, when the load impact is there, any impact load is there, then the load will get transferred to the fiber and fiber will start taking the load by stretching, and then due to the interlacement or it will be the total load point will be actually increased, the deformation through the contact points, the area of deformation will increase. So, that the larger area the load will spread, the impact energy will be absorbed by the larger area. Okay. So, that is non-crimp fabric we can produce by the advanced weaving technology, and also multi-axial weaving, multi-axial, normally what we do, we produce fabric in either in two direction, biaxial, warp and weft. This is warp and other side it is weft. But with the advent of this multi-axial weaving, so this invention helped us to create fabric where the load carrying capacities are almost equally distributed to multiple direction. So, that will help in improving the performance and which will improve the delamination resistance and ballistic performance. Now, if we see here, the problem with the normal weaving, biaxial weaving, what will happen? It will take load in longitudinal and transverse direction. Okay. But this after development of the multi-axial weaving, where the threads can be aligned in different direction, in that case at different direction the load, it will carry the load. Otherwise, in normal fabric it will not carry the load in other direction. So, that is actually the advantage of this multi axial stitching, and also due to this 3D weaving or multi-axial stitching process. So, the delamination is actually resistance is improved. So, that the layers earlier what used to do, the different layer of 2D fabrics were actually used for the multi-layer this composite. But if we use a single fabric with different layers, 3D fabric, where the binding threads are there the delamination problem will be improved. Okay. So, composite the improved manufacturing process enhance the characteristics. So, this we can see that advanced weaving and stitching. So, where we can see that multi axial, the 3D fabric we can produce here, which enhance the performance. Even automatic laying up is also important. So, automatic laying up enhance the efficient production of complex composite structure. So, here using the automatic layup we can produce the complex structure. So, what are the applications of textile composites? So, in the armor, so personal body armors are used for vest, helmet, plates or for military and law enforcement. So, different types of plates we can use the vest. Okay. So, you can see that personal body armor at different. So, this is the vest we can produce, or even so we can have the composite plates, maybe high performance fiber composite plates we can use here. And you can see the weight reduction is tremendous. Weight reduction is there as compared to their metallic counterpart. And this is personal body armor, even vehicle, land vehicle, naval vehicle, aircraft, there we use textile based composite. You can see all these things are textile based composites used in tank, okay, vehicle armor we can use the textile based composite, even structural reinforcement is there. So, here we can use any structure for any apart from the body armor, for any structure. So, enhance the blast and ballistic resistance of building. So, in a building we can, so bulletproof building we can produce, we can have some structure lightweight building where it will be blast proof. So, that for that we can use the textile based composite. Now, what are the challenges of textile based composites and the future directions? The problem with the textile based composite is the first is the cost. Its high performance fibers are expensive, and also manufacturing process of composite is expensive. So, we need a large quantity of high performance fiber. So, for metal, if you see compared to the metal, it is very high expensive. Metal is cheaper, we can have say steel plate. Irrespective of other disadvantages, metal is cheaper. So, that will be an simple manufacturing, but here it is a high performance fiber will be used, which is very expensive, and also manufacturing process. Manufacturing process will be multi-stage manufacturing process. First we have to have weaving, fabric manufacturing, then composite manufacturing, then finishing. Everything will be expensive. And next is the impact of environmental factors, like here long term performance under extreme condition, that we have to see. Depending on the fiber we can have, but matrix material that may get damaged with in the extreme condition. Long term performance will be difficult, for that we have to develop fabric, or we have to develop composite in such a fashion. So, it in the extreme condition that we need long term performance. So, cost we have to reduce, long term performance we have to enhance for this composite material, and then we have to do our proper research in these areas to improve the characteristics of self healing composites. The research area is going on. In case of any damage, so that is the, or anything happens, so self healing composites are in the research. People are doing research on this. Advanced hybrid material system, there are new types of material people are working, and also smart armor with integrated sensors. So, with the inside the armor, so there are systems are integrated. So, different types of sensors are integrated within the sensor, within the armor, so that we get the different types of information from the field, real time information we can get. Like in this composite material, we are producing a armor vehicle. So, here from this sensor we can get different types of information, like what is the temperature, what is the other environmental factor. So, that we can get different types of information. Cost, environmental factors, and different types of research. And the future is composite. So, obviously, that we need all these advantages, like weight, that it should absorb the energy. So, it should be environmentally, it should not get damaged easily. So, the future is composite material. The composite structure offers significant advantages in terms of it is a lightweight, okay, multi-heat capability, as we have discussed. For hard armor or metal, it gets damaged. So, multi-heat capability is there, reduce spall, like your dust particle secondary projectile, it reduces, blunt trauma it reduces, as I have already mentioned, and the basic problem is the with the metal is the heavy single hit, because it is a multi hit capability is not that, it is only single hit. If it damages, then we have to replace. It has a risk of spall formation, secondary projectile, and high trauma, that we have discussed. And the research which are going on in the self healing material, hybrid system we are going, integrated systems, and AI driven design. So, different types of research are going on in this area. So, the advantages of the weight, multi heat capability that we have discussed, spall reduction, and blunt trauma protection. So, for all this we must go for the this textile based composites in future with some modification, some more development, more integration of the electronics or AI driven designs. And next is that it is a design flexibility. So, that textile based composite has got its design flexibility. We can design the armor with different types of design, okay, different body shape, okay, and superior energy absorption mechanism. The energy absorption mechanism of composite we have discussed, by deformation, by spreading the energy. So, this superior absorption characteristics mechanism make them preferred choice for modern ballistic protection. So, that is why it is a superior design flexibility is there. Next is the what are the ongoing research which continues to push the boundaries of performance and applications. So, different types of ongoing researches are going on in this area. Now, let us see what are the future of this composite. So, this future material which we use for ballistic material, it is a composite. So, we have to come out from the heavy metallic ballistic material. So, textile composites structures offer significant advantages over traditional hard metal armor in terms of weight, multi heat capability, spall reduction, and blunt trauma. The design flexibility and superior energy absorption mechanism make them preferred choice for modern ballistic protection. So, ongoing research continues to push boundaries of performance and applications, and for any composite material we have to have proper testing and quality evaluation. So, first we have to check the material, maybe input material or output material, to which will be used for making the composite. So, materials quality check, it should be consistent strength, stringent quality should be there, constant and stringent quality assessment should be there, which allows the raw material used in the vest. So, that the raw material like the filament or fiber we use, for that we have to have constant and stringent checking, quality checking. So, if we want to have best quality of product, so material quality checking is very important, even if it is raw material, in process material and output material, that product. So, constant material checking should be there. Then we have to have ballistic solution evaluation. So, continuous performance evaluation of the ballistic solution against real world threats. So, we must follow the standard, and also the evaluation. So, evaluation process has to be evolved as the real world threats are changing with the time. So, that accordingly we have to change our test procedure, quality evaluation. So, performance evaluation will depend on the real world threat. Exhaustive testing should be mandatory. So, this process to conduct through accredited international laboratories. So, we have to have exhaustive testing, because these are the protective textiles. It is not like if it fails, then we can have second chance, but here there is no second chance. So, for that stringent evaluation will be there, stringent quality checking should be there for this type of material. So, proper quality check to ensure the end users receive the perfect material, receive the best protective armor, because if there is any failure during the test, that person, that material should be rejected immediately. So, proper quality check has to be there. So, it should feature the proven material for enhanced ballistic protection and significant weight reduction. So, proper material we have to select, and which will boost the effectiveness and mobility of the military troop. So, that weight should be reduced, so that the mobility is not restricted. So, military troops, police officer and security personnel. So, all this quality checking should be there. It should not be that should not be too heavy. So, everything should be checked thoroughly, so that we can provide the best protection of our military troops, police officers, security personnel. So, they should be maximum protected. So, for that testing we need standard test methods. So, threat characterization and standardization is must. So, the standards we have to follow stringent standards. So, importance of standards like ensuring consistent protection level and test methods like NIJ 10106 for body armor, NATO for fragmentation. So, this standards we have already discussed, but we have to follow this standards strictly. Stringent measurement will be there as per the standard, strictly standards have to be followed. like the type of bullet, the distance, everything should be followed as per the standard. If there is any deviation, then we should not actually use that standard. So, stringent standard should be followed. So, test methods, that is firing range test will be there. So, different types of test methods we have to follow, like firing range test, velocity measurement, that we will discuss separately in detail, that V50, where the velocity will be that at that velocity the probability of perforation will be 50%, that we will discuss subsequently. But the firing range, at the firing range, what is the velocity of the bullet, that we have to measure. We must know the penetration, how to assess the penetration properly, and also back face deformation. So, all this we have, whatever we have discussed earlier in the particular standard. So, in this NIJ standard or any ballistic material standard, so one is firing range test we have to do, velocity measurement we have to do properly, penetration assessment, back face deformation. So, this we have to measure, test as per the strictly as per the standard, and NIJ standard, any standard in ballistic, they actually specify the particular type of bullet which has to be used, that also we have to follow strictly. So, now if we try to see the overview of the protection mechanism. So, how the textile stops the projectile, that we have already discussed, and that we have to enhance, we have to develop the structure, textile structure, to follow this or enhance this type of mechanisms. So, this is whatever the textile can do, that hard metal cannot do. So, textiles main advantage is that it is not hard. So, textile protects or stops the projectile not by the hardness, because of its softness textile actually gets deformed. So, not by the hardness, but by deformation, delamination. Delamination enhance the due to the friction, it actually absorbs the energy, and by the deformation of fiber and the textile structure, it absorbs the energy. So, due to all these mechanisms, textile material is able to absorb the energy and finally stops the projectile. So, the principle for protection or stopping the projectile are the spreading of energy. This energy is spreaded to a larger area, fiber stretching, due to fiber stretching it absorbs the energy, due to the friction fiber to fiber friction, okay, or yarn to yarn friction, it helps in spreading the energy in a longer area, larger area, also by delamination and by fracture. So, in every stage we see it actually absorbs the energy and dissipate the energy into a larger area. So, the theory of deformation is that mechanism, when the projectile strikes, fiber in the impact zone rapidly stretch and deform, absorbing the kinetic energy. That is the first mechanism, and here the process is the elastic and plastic deformation of the individual fibers and yarn bundles are taking place. One is the elastic deformation of fiber, it absorbs the energy, and also some plastic deformation will take place within the fiber, individual fiber and yarn, that also will take the energy. So, when projectile strikes, due to the deformation of the textile structure, the energy is absorbed. This is the energy absorption theory by deformation. Then energy spreading by delamination, energy spreading and delamination. So, this is the next stage, how the energy gets spread. The energy of the projectile is rapidly distributed away from the impact zone to a wider area of the fabric, engaging more material. So, as we have already discussed, so in a fabric when it is impact, so impact zone is this one, but it will, due to the textile structure, it will spread in the wider range. So, engaging more material, so that more material will absorb the energy. So, that catastrophic breakage of the material or this structure will not take place, like unlike the hard metal. So, here the spreading is there, then delamination, multi-layered system, layers separated, further it absorbs the energy, that we have already discussed. And the weave structure's role is that it facilitates the energy transfer, like the interlacement point. So, at the interlacement point, due to the friction, so suppose at one point there is a bullet hit. So, that due to this interlacement point, so the energy gets transferred to the other threads, multi direction, all the directions that get energy gets transferred due to this weave structure. And the frictional energy distribution due to this friction between the yarns due to the structure. So, fibers slide against each other, fibers or yarn also, it slides against each other and against the projectile. Suppose there is a textile structure, suppose this is a textile structure. Okay. Here the projectile, suppose projectile hits here at this point. Okay. This is the deformation is there. Now, due to this kinetic energy, the fibers, there will be interfiber friction, okay, this against each other, the interfiber friction, and against the projectile. Here when the projectile is hitting the fabric, there will be fiber and projectile friction will be generated, and that will absorb this energy, and which the friction also generates the heat, and this heat is generated which actually dissipates the kinetic energy. So, kinetic energy is actually due to the friction, it is actually heat energy is generated, and that will absorb the whatever energy in the projectile is there, that will also get absorbed. So, multi-layer system is also important, which significantly contribute the energy absorption, like a multi-layer woven or unidirectional fabric also will be important for energy absorption. Then fiber fracture and yarn pull out. So, there are different types of mechanisms are there. So, this we will discuss in the next session. Till then, thank you.